Let's find the answers of a few number of exercise questions from coordination compound. Question number 28. The question is how many ions are produced from the complex in aqueous solution? So when this complex dissolves in water, how many ions will be produced? You can see two chloride ions as the counter ion part, then the complex ion. So when dissolves in water, it dissociates into complex ion and counter ion, right? So one complex ion we get, that is CONH3 6 times to carry, because chloride ions carry 2 negative charge, 2 plus. The complex ion plus chloride ion. How many chloride ion? 2 chloride ion. So total how many ions are produced in solution? 3 ions. The answer is 3 ions. 3 ions are produced in solution. Now question number 28. Which of the following has the highest magnetic moment? Magnetic moment depends on number of unpaired electron. So you need to find the number of unpaired electron present in the central metal atom of these complexes. Here you can see chromium, all the complexes are octahedral. Coordination number 6. Ligands are the same, water molecules. The coordination number, oxidation number of chromium in the first complex is +3, right? Iron also, water molecule neutral ligand, so iron in the second complex +3, zinc in the third one, zinc +2 oxidation. Let's write the electronic configuration. Chromium +3. Chromium, we know electronic configuration of chromium atom, atomic number 24. Electronic configuration is 4s1 3d5. Chromium 3 plus ion, the configuration will be 3d3. Right? 3 electrons removed. From chromium atom, we get 3d3 configuration. Now, Fe+3. Fe+3 configuration means iron, atomic number 26, electronic configuration 4s2 3d6. So the configuration of Fe3 plus ion will be 3d5. Fe H2O 6 times 2 plus. It's not 3 plus, 2 plus given in the question. So what will be the oxidation number of iron? +2. Iron +2. So the electronic configuration, 2 electrons gone. So 3d6 is the configuration of iron. Now zinc 2 plus, zinc atomic number 30. Electronic configuration 4s2 3d10. Zinc 2 plus, the configuration will be 3d10. So these are the electronic configuration. So tell me how many unpaired electrons, because water molecules are the ligand, weak field ligand, no pairing takes place. So electronic configuration of this metal atom in the complex will be the same as the free metal ion configuration. So 3d3, 3d6, 3d10. How many unpaired electron in 3d3 configuration? 3d3 configuration means there are 3 unpaired electron. 3d6 configuration means one diatomic orbital, there is pairing. Paired electron. So remaining 4 unpaired electrons are present in 3d6. 3d10 means no unpaired electron, 0. Unpaired electron 0. So maximum number of unpaired electron present in FeH2O 6 times 2 plus complex. That is n value equal to 4. Means maximum highest magnetic moment will be there in second complex. So the answer is this one. Iron H2O 6 times 2 plus contain maximum number of unpaired electron, hence highest magnetic moment. Now the next question, what is the oxidation number of cobalt in the given complex? We know the counter ion potassium +1, so the charge on the complex ion will be -1. Carbonyl ligand, neutral ligand, no charge. So cobalt here will be in an oxidation state of -1. What is the oxidation number of cobalt in this complex? -1. Question number 31. The most stable complex in the among the following. 3 complexes are given. 4 complexes are given. In all the complexes, central metal atom is iron. The charge on the metal ion also correct. The same. Octahedral complexes. Ligands are different, right? Here water molecules are the ligand, ammonia, here oxalate ligand, here chloride. So which ligands will form most stable complex? Here you can see water molecule, NH3 and chloride. All these are monodentate ligand. But oxalate ion is a didentate ligand. It can form chelate complex. This is an example of chelate complex. So didentate ligand or oxalate is a chelate ligand. It can form cyclic structures and this complex is more stable. Chelating ligands produce more stable complexes than monodentate ligands. So this is the more stable or most stable complex is the one with the oxalate ion, because oxalate ions are chelate ligands. Now the last question. 3 complexes are given. 3 nickel complexes are given. What is the order of wavelength absorbed from the visible region for these complexes? You need to arrange these complexes in the order of wavelength of absorption. So here you can see all the complexes are octahedral complexes. Central metal ion the same. Coordination number 6. Only ligands are different. The energy of absorption. The energy absorbed by each complex depends on what? Energy absorbed by each complex ion depends on the crystal field splitting energy, right? Energy of absorption, energy absorbed from the visible region by these complexes depends on crystal field splitting energy, that is delta O. And this delta O value depends on strength of the ligands. Strength of ligands. In the spectrochemical series, we see that the order of strength, ligand field strength of these ligands is in the order water molecule, the weakest field ligand, then comes ammonia, and the strongest field ligand is NO2 minus, nitrite ion. This is the order of field strength. Field strength of ligands is in this order. Field strength in this order means this is the order of crystal field splitting energy. As the field strength of the ligand increases, delta O also increases. That is, crystal field splitting increases. So when the crystal field splitting energy increases, energy of absorption also increases, right? So what will be the order of energy of absorption? So this will be the same as the order of energy absorbed by this complex. Means minimum amount of energy is absorbed by the complex with the water ligand, then with the ammonia ligand. Maximum energy is absorbed with the NO2 minus ligand. We know the relation between, here we need to find the order of lambda. Lambda of absorption order we need to find out. You know the relation between energy and lambda. Energy is equal to h nu. Planck's equation, where h is the Planck's constant, nu is the frequency. We need to bring lambda, wavelength, into this equation. We know h into frequency nu is equal to c by lambda. We know, right? So how energy and lambda related? Energy and lambda inversely proportional, right? If this is the order of energy, the order of lambda absorbed will be the opposite order. Means higher the amount of energy absorbed, lower the lambda of absorption, wavelength. That means which is having the lowest lambda of absorption? The complex with the highest energy of absorption. That is nickel NO2 minus 6 times 2 plus. This complex is having the minimum lambda of absorption. Maximum energy, that means minimum lambda of absorption, than nickel NH3 complex. NH3 6 times 2 plus. This is not 2 plus, 4 minus. And maximum lambda of absorption will be with the weakest ligand, that is nickel water molecule. 2 plus. This will be the order of lambda of absorption by the ligands. That is just the opposite order of energy of absorption. opposite order of delta O, or opposite order of field strength of ligands.